بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Today we're going to continue talking about logarithmic functions part 2. Let's begin with the domain of definition of a logarithmic function. Let f be a function defined as f of x equals ln u of x. The function f is continuous and differentiable for all x where u of x is greater than 0. Find the domain of definition of each of the functions below. F of x is ln x. So applying the definition, we can say that f is defined for x is greater than 0. And in this case, x plays the role of u of x. So the domain of definition would be 0 excluded plus infinity. F of x is ln 2x minus 4. So f in this case is defined for this quantity greater than 0. So 2x minus 4 is greater than 0, which means that x is greater than 2, and the domain of definition of f is 2 excluded plus infinity. This function, f is also defined for 4 minus 2x is greater than 0. We are still applying the same definition. So x is smaller than 2. Pay attention here, we have to flip the inequality sign because we are dividing by negative 2. So the domain of definition is negative infinity to excluded. Fourth example, this is f of x. Again, f is defined for x squared plus 3 is greater than 0. And this in fact happens when x belongs to R, because x squared plus 3 is always positive for any x. So the domain of definition is negative infinity, positive infinity. And finally, f of x is ln of 2x minus 6 plus ln x. In this case, pay attention, we have two conditions at the same time. So we have to say that f is defined for 2x minus 6 is greater than 0 and x is greater than 0. So here we have two inequalities at the same time or simultaneously. Remember, to solve such a system of inequalities, we solve each inequality alone and then we find the intersection of the solutions either mentally or using the number line. Now for the first inequality, it's easy, x is greater than 3. And for the second inequality, x is greater than 0. And if we want x to be greater than 3 and greater than 0, this means that x is from 3 to plus infinity excluding 3. Here we can also use the number line to find the final answer. So till now we know that if f of x is ln u of x, then f is defined for u of x is greater than 0. But pay attention, after we put u of x to be greater than 0, we have to search for x. Find the domain of definition of each of the following functions. The first one, try to find it alone. So in this case, f is defined for x is greater than 0. So the domain is 0 plus infinity. The second case, also f is defined for x squared plus 3x minus 4 is greater than 0. This is a second degree inequality. Remember, we compare to 0, we factorize, we find the roots, we construct a sign table, and then we find the final result. The roots in this case would be negative 4 and 1, and applying same opposite same, we get this table of signs, and we need it to be positive, so the domain of definition is negative infinity, negative 4, union 1 plus infinity, all excluded. Now this function, in fact here we have two conditions, so don't forget to put it as a system. So f is defined for x minus 1 is greater than 0 and x plus 4 is greater than 0. For the first inequality, x would be greater than 1, and for the second, x would be greater than negative 4. If I want x to be greater than 1 and greater than negative 4, this means that x would be greater than 1, and the domain of definition is 1 plus infinity, both excluded. Now, we're going to go on to the second part of the chapter, which is equations of logarithmic functions. A and B are two strictly positive real numbers. Ln A equals ln B if and only if A equals B. In other words, if I know that ln A equals ln B, I can eliminate a ln from here, a ln from there, and vice versa. If I know that A equals B, I can apply a ln here and there. Solve each of the equations below. Part A. Ln x equals ln of 2x minus 2 for x belongs to 1 plus infinity. So applying property 1, you can eliminate ln from here, ln from there. We get x is 2x minus 2. So x is 2. Now 2 is accepted because it belongs to the domain of definition. Another equation, we also eliminate ln from here and there. We get x is 2x squared minus 1. So 2x squared minus x minus 1 is 0. The roots are 1 and negative 0.5. 1 is accepted because it's in the domain of definition, whereas negative 0.5 is rejected because it's not in the domain. Now ln x is ln 5. So simply x is 5 and it is accepted. Notice here, if the root is accepted, we don't have to write the word accepted, whereas if it were rejected, we have to write rejected. Now, another type of equations, ln x is 1 now. So we have ln on the left side, but we don't have ln on the right side. In this case, simply we try to translate 1 into ln, and we know from before that 1 is ln e. So ln x is ln e means that x is e and it is accepted. Now what happens in case I have ln x equals 5? Ln x is 5 and 5 is 5 times ln e because ln e is 1, and applying the properties of logarithm we get ln of e to the power 5. So ln x is ln e to the power 5 means that x is e to the power 5. In fact, this procedure could be used directly. I mean, if ln x is 5, I can automatically say that x is e to the power 5. So here, ln x is negative 7. We can automatically say that x is e to the power negative 7, applying the same procedure in part E. Let's see the list. Ln A is ln B if and only if A is B. And remember, if ln x is k, this means that x is e to the power k and vice versa. So x is directly e to the power k. Solve. Unless stated, we suppose that x is strictly positive and y is strictly positive. Ln x equals ln minus x plus 2 for x belongs to 0, 2. Try to do it alone. Check up your answer. So applying ln a equals ln b if and only if a equals b, we say that x is negative x plus 2. So x is 1 and it is accepted. 2 ln x is 6. Ln x is 3, so x is e to the power 3. Now ln x is negative 1. So x is e to the power minus 1. Ln x is 0. So x is e to the power 0, which is 1. Part E. In fact, here we have a zero product equation, so we have to suppose that each factor is equal to 0. So ln x minus 1 is 0, which means that ln x is 1, so x is e. Or 4 minus ln x is 0, which means that ln x is 4 and x is e to the power 4. And in this case, both answers are accepted. Well, ln x quantity squared minus 2 ln x is 0. If we take ln x as a common factor, we get ln x minus 2 is 0. So ln x is 0 or ln x minus 2 is 0. The first one leads to x equals 1 and the second leads to x equals e squared. 2 ln of x quantity squared minus 3 ln x minus 5 is 0. Try to do it alone. Well, here we're going to use a change of variable. We let t be ln x. The equation is translated into 2t squared minus 3t minus 5 is 0. We search for t. We get t is negative 1 or t is 2.5. But remember, we are not searching for t, we are searching for x. So we go backward to the relation between t and x. So ln x is negative 1 or ln x is 2.5, which means that x is e to the power negative 1 or x is e to the power 2.5. Now here we have a system of two equations with two unknowns. The two unknowns are x and y. Try to do it alone. Well, here we apply any method of the system of two equations with two unknowns, like let's say substitution, comparison, elimination, any method that we saw in grade 9. What I did here is I used elimination. If I multiply the first equation by 2, I get 2 ln x plus 2 ln y is 2, and 3 ln x minus 2 ln y is 13. If we add, we get 5 ln x, ln y and ln y are eliminated, equals 15. So ln x is 3 and x is e to the power 3. Now to find ln y, we choose any one of the two equations or any one of these equations. Ln y from the first one is 1 minus ln x, which is 1 minus 3. We know from before that ln x is 3, which is negative 2. So y is e to the power negative 2. Thank you.